Good morning. Welcome back to the Caddy Daddy's garage. Well, you've seen the cruise control unit get taken apart. You've seen it get put back together. Now you're going to see it in action and see how it works on the inside. You might be wondering what this setup is. Kind of a intriguing mess of power supplies, batteries, cordless drill, a cruise control. My goal today is to give you a demonstration of what goes on inside the cruise control unit, one of these electromechanical units. So I had to do something to simulate a Cadillac or a BUICK, Oldsmobile, Imperial, whatever, going down the road, because you can't very well be looking inside this while you're driving down the road. So what I've done is, this is the linkage to the carburetor. It's going to this cordless drill switch. So as you can hear that it's controlling the drill at the other end. So as the cruise control is asking for more throttle, the drill speeds up. As it asks for less throttle, it slows the motor down. So this is simulating the powertrain, and now we got the drill motor simulating the engine, pushing the car. Thing that we don't have is a couple of tons of car going down the road. So the best thing I could do is, on the output of our motor here, this disc here is a target out of an X-ray tube. It's a piece of pure tungsten. It's very heavy. It's to kind of to give some lag to the action, so that the drill has something to work against to simulate the momentum of the car. Just using a piece of rubber tubing here to connect it to the cable. To simulate the car going up a hill, I'm just going to rest my hand on the tungsten disc. It'll slow the motor down. The cruise control will see that it's slowing down, and will give more throttle to speed things back up again. To simulate going down the hill, I'm going to take and put an extra resistor in the parallel series here, which will cause a greater voltage to the motor to cause it to speed up like you're coasting down the hill. So the cruise control is going to ask for less throttle to try to slow in the vehicle. So the next thing we're going to do, I'm going to show you the inside of this unit. You've seen it taken apart, and you've seen it go back together. And so I'm going to explain how it all kind of works together as a complete unit. Okay, now that you've seen the external setup that we've got going to simulate this unit actually being an automobile, let's look at what goes on inside. Down on the bottom, we have a motor. That motor operates this lead screw. Lead screw has a very interesting clutch mechanism, which you've seen during the rebuilding process. So the lead screw moves this unit that pivots on the main shaft. This is the part that goes to the carburetor, and it's allowed to move freely when this is parked. This is the park position. There's a set of contacts underneath that run the motor all the way to this position and stop. And that's where this power lead here. This power on this terminal is constant when the unit is turned off, and that is the parking signal. This terminal here is a turn on signal. So when you turn the unit on, this terminal has power applied. And then when you press the lock-in switch, the lock-in switch will pull this in. And what I'll do is I'll disconnect this for a moment so we don't have to hear the motor run. So the lock-in switch does that, and it will lock in if you manually push it. So that's what couples the solenoid pulling this in. When you press lock-in, is what allows the lead screw to move this whole section back and forth to control the throttle. We'll let that loose. Now, what controls the motor are these switch contacts. There's common here in the middle, and then there's accelerate and decelerate contacts. That center contact is operated by this flyweight governor. You guys probably heard the term running balls out. That comes from these old mechanical governors. In the old days on the steam engine or an old tractor, instead of square weights, it would have balls, steel balls. And as the unit spins, centrifugal force pushes the balls out. And so when something is running at full speed, the balls are all the way out, hence the expression. So as the weights move out, it pushes this plastic collar, which in turn is tied to these electrical contact. The resistance on the weights flying out is controlled by this plunger here, and this is coupled to your control on the dash for setting the speed. So the higher the speed you set, the more that is pulled in. So what we're going to do is I'm going to go ahead. It gets noisy here when I run it. I'm just going to initially power it up. We'll run the motor up like we're just driving down the road. We'll turn the cruise control on, and then we'll lock it in and watch it hold the speed. And then I'm going to go over, when you see me go back here and touch this, I'm slowing it down. That simulates going up the hill. And when you see me reach here and connect this resistor, that's speeding the motor up, simulating going downhill. So what you'll want to be watching is between these contacts here, you'll see this center contact slowly hunt up and down as the governor weights move in and out depending on the speed and the amount of resistance here. And it will probably at some point start really hunting, where it starts making violent motions. And that's simply because we just don't have enough inertia and mass in the system. Like I say, we don't have a couple of tons of car. So let's start it up. So we're going to say we're cruising down the road. We're going to turn the unit on. And you can see that this is coming up. And this is the way, see, when I'm up against it, it's trying to resist me. And that is the feature that you can use on the cruise control, where when you turn it on, it helps to remind you not to speed. Because this will hold at the fixed position so that you come against resistance if you try to push the gas pedal down more. That's what this spring is for, is to actually let you power through it with your foot. So now we're going to tap lock in, and you'll see that solenoid pull in and latch. So now the speed is being controlled by the mechanism. You can see the terminal move, remembering that coming this way accelerates and that way decelerates. Now if you wanted to set the adjuster for a little bit slower speed on the road, you take your dash control and you turn it out a little bit, and you can hear the motor slowing down. And it's hunting a little bit. You can see, and that's because there's just simply not enough mass. So we're going to set it at a speed that it's fairly stable at. And actually having it hunt and act out lets you really see exaggerated what's happening. So I'm going to come over here and put my hand on the motor, slowing it down. You can see it trying to open the throttle to give more speed. We'll let it settle down. I'm going to increase the voltage of the motor. And you can see it came back towards me, which is closer to idle. Now we'll let it go back to normal. Start to settle down. And you can pretty much hear that the motor is trying to run at a constant speed. And when you shut it off, we'll hold this like we put our foot back on the gas. We've dropped the lockout solenoid, and now we're going to turn it off, and this is going to go all the way down and park. Just like that. And now we're free to operate the throttle normally. So that's a little bit of what goes on inside of here, and when it is hunting like that, then the movements here are exaggerated, but normally it just slowly goes between the 2 points. You come up into a hill, it'll see that you're slowing down. The contact will close. It'll give more throttle. So these older ones, not quite as steady with their speed as the more modern ones are, but it is an electromagnetic setup in here, motor, the solenoids. It's just really kind of a neat setup. Thought you guys would enjoy seeing it, seeing the inside, and actually seeing what goes on inside. So thanks for stopping by the shop, and hope you enjoyed the video.
Vine Village is a great organization that gives back to the community. Check it out. You'll see so as well. Thanks for watching.
Hi, my name is Sanan Kirsten. We're here at the 2018 Vine Village Celebration, our major fundraiser here that helps fund programs that we run for people with developmental disabilities here in the greater Napa community. Vine Village was founded by my family and another family, each who had children with disabilities, in 1972. We depend on donations from all sorts of foundations and individuals and businesses throughout our community to help fund these programs, and this is our biggest fundraiser of the year.
You can donate by clicking the link in the video description.